Welcome to the online tutorial over pH calculations for academic chemistry. In this tutorial, I will be using the Guide to pH Calculation sheet as well as referencing back to your acids and bases notes. So have both of those in front of you, as well as a calculator that has the ability to do log functions. Okay, so you'll need a calculator as well. Okay, before we actually start with our calculations, I want to draw out what a pH scale looks like and what a pOH scale looks like. Because more important than being able to do the calculations is to identify the solution as an acid or a base. That's the whole purpose, right? So, if you have the pH scale, what does it look like? Okay, well, it ranges from 0 to 14 with 7 in the center. Anything less than 7 is an acid. Anything greater than 7 is a base. Now, what if it is exactly 7? If something is exactly 7, it's neutral. Okay, so contrasting this with the pOH scale, again, it ranges from 0 to 14. 7 is still in the center, and yes, 7 is still neutral. But this time, acid and base has flip-flopped. So less than 7 means something is a base. Greater than 7 means something is an acid. So these scales are opposites of each other. Okay? So let's use them. I'm drawing a line under section 2 because section 1 and section 2 type of problems use the same equation. Okay? So instead of having 8 separate sections, let's just have 4 separate sections here. Using the equation pH plus pOH equals 14, I'm able to solve for either variable. Okay. In group 1, I'm solving for pOH. In group 2, I'm solving for pH. All right. So let's do a problem like B. If they give me that the pH of something is 3, they're asking me to solve for pOH. So how do I do that? Well, plug 3 in to the equation and solve for your unknown. So now I have 3 plus pOH equals 14. If you subtract 3 from both sides, pOH is equal to 11. Okay, and you're going to have to excuse my smartboard for some reason. I think when it gets hot, it gets squiggly. So that is an 11. Okay, now let's think about this. What does that mean? If I get a pOH of 11, on the scale, it's somewhere over here. So that means that this is an acid. This is an acidic solution. All right? Okay, then with type 2 problems, it's the same sort of thing, except you're given pOH and asked to solve for pH. So, for example, I would plug 10 in for pOH, and I would discover that pH would then be 4. So with a pH of 4, you could look on the pH scale. This is an acid. Okay, pretty simple. These two types of problems are simply solved by subtraction. Okay, I'm going to move on to problems like 3 and 4. So scroll down. Put a line under number 4. Again, we're grouping these because they have the same equation. The equation is if you multiply the hydrogen ion concentration and the hydroxide ion concentration in a solution, it's going to equal 1.0 times 10 to the negative 14th. Okay, so I'm going to use this to solve for either variable. If I'm given the hydrogen ion concentration, I can solve for hydroxide. If I'm given hydroxide, I can solve for hydrogen. And the way you solve for these is by dividing. Again, you'll simply plug in what you know and solve for your unknown. So let's do H. I know the hydroxide ion concentration, so I'm going to plug it in. And your formula should now be the hydrogen ion concentration times hydroxide ion concentration. I'm sorry. You're plugging the number in for the hydroxide ion concentration. So it's the hydrogen concentration times 7.3 times 10 to the negative 12 is equal to 1.0 times 10 to the negative 14. Okay, how do you solve for the hydrogen ion concentration? Divide both sides by 7.3 times 10 to the negative 12. Basic algebra. On the left side, it cancels. And when I plug this into the calculator, I get my answer. Okay, so I get the answer that the hydrogen ion concentration is equal to 0.0014. Okay, so if it's 0.0014, you have to change this into scientific notation, okay? And you change something into scientific notation by moving the decimal place. So I move the decimal place 1, 2, 3 times to the right. So in scientific notation, this number is 1.4 times 10 to the negative third. What do you do with a number like that? Okay. The reason this information is so useful is that if you go to your notes, there is a chart in your notes. Let me clear this. There is a chart in your notes that helps you to figure out if you have a hydrogen ion concentration that is greater than or less than 1.0 times 10 to the negative 7, you can figure out if it's acidic or basic. Now remember, we just solved for a hydrogen ion concentration of 1.4 times 10 to the negative third power. Okay. You have to be able to look at this number in scientific notation and know that this number is greater than 1.0 times 10 to the negative 7th. So that means, looking at the scale, I have an acidic solution. Okay. So I'm going to go back to the other page. We were on problem H. So the answer would be that the hydrogen ion concentration is equal to 1.4 times 10 to the negative third, and that it is acidic. Okay? Now, type 3 problems are solved in the same manner, okay, by division. Okay, so for example, like letter E, you plug in this hydrogen ion concentration into the formula and you would solve for OH. Okay, so when you get your hydroxide ion concentration for this one, you should get 1 times 10 to the negative fifth. Is that correct? 1 times 10 to the negative fifth. Okay. Then you can look back on your scale. Okay. This time, it's for the hydroxide ion concentration. Which is here. And the number was times 10 to the negative fifth. This number happens to be larger than 1.0 times 10 to the negative 7th. So if it's larger than on the hydroxide ion scale, it's basic. Okay, so we would be able to say that E is basic. Okay, all right, let's move on. Moving on to types of problems like 5 and 6. So again, draw a line under number 6. The equations for solving these two types of problems are the same. You will do a negative log of the ion. The only difference is you're either solving for pH or POH. So let's do J together. I have a hydrogen ion concentration of 3.5 times 10 to the negative 10th. I know in order to solve for pH, I'm going to plug this number into the equation. So in your calculator, this is what your screen should look like. Negative log 3.5 E time, 3.5 E negative 10, close your parentheses. Okay. How do you get your calculator screen to look like that? If you're using a calculator that we use in class, which is a graphing calculator, I'm looking at TI-84 right now. The log button is to the left of the number 7. So first you have to hit the negative button, not the minus button, but negative, which is kind of to the left of the enter button. So negative, then hit log 3.5. Now to get E, remember that stands for times 10. You hit second, comma, okay? Comma is located above number 7. You should have a capitalized E in your screen and then hit negative and 10, close your parentheses. When you hit enter, you get 9.455931956, blah, 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 blah. However, you need two significant figures. So your pH comes out to 9.5. Okay, remembering your pH scale, you should be able to identify this as a basic solution. Pretty simple, right? As long as you know how to plug these in your calculator, you should be fine. And to solve for POH, same sort of thing, except you're plugging in the hydroxide ion. So you would do for K, for example, negative log of 1.0 E, negative 3, and you get a POH of 3. Remembering your POH scale, this would be basic. Okay, and on to the last type of problem, which is 7 and 8. 7 and 8 are just the opposite of 5 and 6. Instead of being given the hydrogen ion concentration to solve for pH, you're given the pH to find the hydrogen ion concentration. So it's just the opposite. And here, you'll hit second log and then put in the negative pH. Okay. I personally tell my students that they can just put 10, use the caret, and put in the negative of whatever, pH or POH. Either way, it works the same. Okay, so let's do N together. If I'm trying to solve for the hydrogen ion concentration, what I would plug in my calculator is 10 caret, or second log, then negative 10.5. I think the most common mistake is to forget this negative sign, so make sure to do negative, okay? And it's different from the minus sign, so make sure you hit negative. You hit enter in your calculator, and you get a concentration of 3.16 times 10 to the negative 11. Okay, now I just solved for hydrogen ion concentration. The exponent is negative 11. So let's look at our notes and see if this is acidic, basic, or neutral. Hydrogen ion concentration. My exponent was times 10 to the negative 11. Okay? Negative 11 is very, very small. Definitely smaller than times 10 to the negative 7th. Okay? So this is a small number. Okay? So this would be a basic solution. My smart part's being difficult. We just solved for N. I said it was basic with a hydrogen ion concentration of 3.16 times 10 to the negative 11. Again, if you're going to solve for the hydroxide ion concentration, like numbers 8, like problems 8, same sort of thing. Okay, so for P, we would do 10 carat to the negative 52, 5.2, sorry. And you get 6.31 times 10 to the negative 6. Your exponent is negative 6. This time, that number is larger than, I'm sorry, this is larger than 1.0 times 10 to the negative 7. Okay, so negative 6 is larger than negative 7. So, go to your notes. This time we solved for hydroxide. So we're looking at this portion of the scale. We said it was larger than, I'm sorry, so it was larger than, which is the bottom one, 1.0 times 10 to the negative 7. So we have a basic solution. Okay. And that was P as basic. Right? So, in essence, what we expect from you to do these pH calculations, we don't only expect you to know how to solve for each different variable. We expect you to know if it's an acid, a base, or neutral solution as well. Okay? Hopefully this tutorial helped you. If you need additional help, there's some on the website. Also, we are available after school for tutorials, so come and see your teacher if you need additional help. Okay, that's all I have for you today. Have a great afternoon, and please do your homework tonight. It's very important.